Hi everyone. Today we're going to talk about empirical and molecular formulas. You simply need the single note sheet set, the assignment that I gave you in class, and your periodic table. Oh, and a calculator. If I go too fast, I apologize. I just recorded this and the sound didn't record, so I'm back to my old microphone. We're just going to start here. So empirical formulas are the lowest whole number ratio of elements in a compound. Empirical formulas are calculated by using the percent composition. So you are going to be given percentages of elements, and you have to figure out what formula is that. Is it carbon dioxide? Is it carbon monoxide? What is it? All right, so I'm going to walk you through. There's really just 3 steps that you have to do in order to be able to figure out what those numbers are that go down there with that formula. Alrighty. So first, the empirical formulas are the lowest whole number ratio of elements in a compound. So when you look at a bunch of different compounds, you should be able to just see, can you reduce that compound down? If you cannot reduce it any further, then that is an empirical formula. So like this compound right here, carbon dioxide, is an empirical formula because I cannot reduce it anymore. This next one, though, if you actually look at it, I could divide both of the numbers in this problem by 2. That makes this a molecular formula, not empirical. This next one, I could divide both of those by 7 and reduce that. So this is a molecular formula. Going back up to the top here, I cannot divide this anymore. That makes that an empirical formula. I can divide both of these numbers by 2, molecular formula. And I can divide both of these numbers by 10. So that is also a molecular formula. All right, so we are going to calculate empirical formulas, and then I'm going to show you how to go from your empirical formula to your molecular formula. All right, so again, you need your calculator for these. Okay, so this question says find the empirical formula of a compound that is 50% sulfur and 50% oxygen. So step 1 is simply to change your percents into grams. You just do this by saying that your percent is grams. Percent means out of 100, so if I had a 100-gram sample of this, 50 grams of it would be sulfur and 50 grams of it would be oxygen. So I'm just going to write that, 50 grams of sulfur, 50 grams of oxygen. Remember, I'm trying to figure out what numbers would go in those boxes. Like, is this SO2, SO3, S2O4? I have no idea. So then I'm just going to take these. So these are my grams. The second step here is to change your grams into moles. You can do this pretty easily just by dividing by the molar mass of the substance. So for 50 grams of sulfur, I will divide that by its molar mass, which is 32.1. Oxygen, I will divide that by its molar mass, which is 16.0. When I do that for sulfur, I get 1.558. I usually go out as many places as I can at this point. Right? And when I do that for oxygen, I get 3.125. Right? Now, obviously, I can't put those numbers in those boxes because we just said it's the lowest whole number ratio. The easiest way then to switch these into whole numbers is not to round, because that is not correct. This is not a rounding problem. What I have to do is figure out that ratio. To do that, the easiest way is just simply take all the numbers in your list now and divide them all by the smallest number there. So when I look at these two numbers, 1.558 is the smallest, so I'm going to divide both of these by 1.558. Same thing here, 1.558. I can do this one in my head. That one gives me 1. And when I divide this one out, that gives me a value very, very close to 2. So those are my two numbers that I am going to plug in here. It's going to be S1, O2. So that is my empirical formula for those percentages. All right. I'm just going to keep going here, and you guys can pause at any point that you want and take a look at that again or rewind it. So I'm going to go on to this next one over here, and I'm going to leave those 3 steps there so that we can see. So I'm going to find the empirical formula of a substance that is 29.5% calcium. So I'm going to write 29.5 grams. 23.6% sulfur, so I'm going to change that to grams, and 46.9 grams of oxygen. Step 1 is now done. I'm going to move on to step 2, which is to divide all of these by their molar masses. The molar mass of calcium is 40.1. The molar mass of sulfur, 32.1, and the molar mass of oxygen, 16.0. So I'm going to take all of these and divide them out. 0.735 for this one. I get 0.735 for this one. And I get 2.931 for this guy. Now I'm on step 3, which says to divide all of those numbers by the smallest number in the list. The smallest number is 0.735, so I know that gives me 1. I'm going to divide that one by 0.75. That will also give me 1. And now I'm going to divide that one by 0.735, and this time when I divide that out, I get something super duper close to 4. So now these are my 3 whole numbers that I write in my formula. I've got Ca1, I have S1, and I have O4. So that is my empirical formula for those percentages. This third one is a little bit different. It follows a different step near the end. And then we'll move on to molecular formulas. So this one right here, it looks like it's going to be the same. The empirical formula of a compound that is 70% iron and 30% oxygen. So I'm going to follow my steps. I just did step 1. Now I'm going to do step 2. I have to divide this by its molar mass, which is 55.9 grams. Divide this one by its molar mass, which is 16.0 grams. 70 divided by 55.9 is 1.25. 30 divided by 16 is 1.875. Step 3 is to divide all of those by the smallest one, so this is the smallest number in the list. 1.25 divided by 1.25 is 1. 1.875 divided by 1.25 is 1.5. So now I ran into a little problem because I cannot put this number in as part of my formula. So when I'm writing out my formula, I know it's Fe something, O something, but I cannot put that 1.5 there. Sometimes you have this extra step. This extra step is to double if you get anything really, really close to a 0.5. Right? I'm not rounding it, I'm doubling it. 1.5 times 2 is 3. But whatever you did to one of them, you have to go back up and do it to everything else. So 1 times 2 is 2. So those are my two numbers. I should have Fe2O3. Final formula. So once in a while, again, that keynote here, double all if any are 0.5, right? Double all if any of them are 0.5. All right. Again, pause at any time and go back and take a look at those. I'm going to move on to molecular formula. I've just got one of them here, but it's on two different squares. So a molecular formula, all that is a multiplier of the empirical formula. It's not necessarily the lowest whole number ratio. No big deal. Same thing. You're going to find the empirical formula. You are going to use the molar masses to find what we're going to call the multiplier. And from that multiplier, you can find the molecular formula. All right? Looks like it's going to take a lot of work. It's not. You're doing the same thing that you did. You're going to find that empirical formula, then you're going to do something here with a molar mass to get a multiplier. Boom, you'll all of a sudden have the molecular formula. All right? So down here we have the same problem on here twice. All right, just so on one I can calculate the empirical formula, and then I'm going to switch that over and show you how to get that into the molecular formula. So I'm just going to calculate the empirical formula here first. So I've got 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. Divide them all by their molar masses and get some numbers here. So this number is 3.33, 6.7, 3.33 again. Third step is to divide these all by the smallest in the list. That is 3.33. So here I am going to get 1, here I'm going to get 2, here I'm going to get 1. Great, those are my numbers. C1H2O1. But that is simply my empirical formula. All right? I have to take my empirical formula and switch it into my molecular formula. So that is what this next step is going to do for you. All right, so again, same problem. I'm just going to continue this here. So as I read the problem, I remember, okay, I've got my empirical formula. I already found that, CH2O. All right. I'm going to read the problem again. In the problem, I know I have to do something more because it told me that the molar mass is 180 grams. Well, the molar mass of this is not 180 grams. Right? So let's add that up. The molar mass of this, see, I'm saying it's telling me the molecular formula's molar mass is supposed to be 180. I know it's not. It's 12 plus 2 plus 16. That's 30. Right, so that's not even close. But what I have to do is figure out my multiplier. I have to figure out how many times bigger is my molecular formula. Right? The way that I usually do that is I just kind of do it in my head. I can see how many times bigger this is. But to really get your multiplier, if you wanted a formula for that, your multiplier is the molar mass of your molecular formula divided by the molar mass of your empirical formula. All right? So if I were to do that here, I would have 180 divided by 30. So when I divide that out, I get a value of 6 here. That is my multiplier. So what does that tell me? That tells me I'm supposed to take everything in this formula here and multiply them by 6. I cannot just put the 6 in front of it because that's not really changing the formula. So my final formula here should be C6, H12, O6. And that is the final answer to that problem. Alright, so your homework then is to do this worksheet that has the empirical formulas. These are done the same way as in the notes. There are 6 of them. Make sure you show all your work. Follow the 3 steps. And then this other side is the determining molecular formulas. The first 2 on here are a little bit easier than the others, so sometimes it throws you guys off. So you might want to start with number 3 and follow the instructions that I gave in the notes. Go 3, 4, 5, then maybe go back up to 1 and 2. Enjoy your weekend and have a great day.